All right, welcome back, B's and G's. Another session of Drive-Through Confessional brought to you by the deli. Hungry? Go to the deli. Get yourself a sandwich. This is question 13 in 4.2. The case of the missing diagram. It says, if each pair of opposite sides of a four-sided figure are congruent. Holy jeez. I think they're talking about a parallelogram there. That's a weak parallelogram. We're going to redraw it. Alright, not great. If each pair of opposite sides of a four-sided figure are congruent, then the segments joining the opposite vertices bisect each other. So they're saying the red segment will bisect the black segment. Gonna need some letters. Let's go with gonna go with brain, not Brian. Brain. Okay, so to do this, we're going to need to show that BN is congruent to NA and that RN is congruent to NI. This is going to be a long proof. We're going to need all the room we can get. So let's see. I'm going to do something like this. Here and like this. And we're going to like just box this in and say this. Okay, step one. BI is congruent to RA. BR is congruent to IA. And that's all that we have given, peeps. Alright. Hang on, here we go. So, let's say that RI is congruent to RI. And that gives us reflexive. Or that's reflexive. Okay? And then we could say that triangle, let me make sure I do this right, triangle BRI is congruent to triangle AIR. I got to check this similarity statement real quick to make sure that I've written it in the right order, because that's going to be the key to this proof. So, started out with what looks to be an obtuse angle, and then I went down the long side and then down the red side. And then I started out with what appears to be an obtuse angle. I went down the long side and down the red side. That is correct. So now I can say that, well, I'll tell you what, I'll wait for my CPCPC. Let me go the other way now. No, I don't think, actually, let me go to this. I can say that angle AIR is congruent to angle BRI. And I can also say that angle ARI is congruent to angle BIR. Notice that wasn't that difficult because I spent some time making sure that my congruent statement was right. So all I did was look at the order on here and use those to write that next step. Let's mark this carefully. AIR is congruent to BRI. ARI is congruent to BIR. Okay, so not enough to prove that, for instance, I want to prove this triangle on the left is congruent to this triangle on the right is congruent to this triangle on the left. Or I want to prove that this top triangle is congruent to this bottom triangle. We don't have enough yet. So now I could say that triangle, oh sorry, that side BA is congruent to AB by reflexive. And now I can say that triangle bar is congruent. Let's see, this time it went down the diagonal first. BAR is congruent to ABI. Not BAB, bar is congruent to triangle ABI by side, side, side. I'm going to check that again. Let's see, BAR, I went from the obtuse down the black diagonal up the short side. ABI, I went from the obtuse down the black diagonal down the short side. Okay, that's good. So what I really need is that triangle R, or sorry, angle RAB is congruent to angle IBA. Let me mark this, see how it looks. All right. Don't forget, because I never marked them in the first place, we know this, and we know that. Now you can see where we're going a little bit better. The reason for 7 was C, P, C, T, C. The reason for 8, well, now we're going to say that triangle BNI, again, I got to go be careful with my congruence here. BNI, I started with this angle with the slash in it, and I ended at the double. So I got to say ANR. Clearly that's an 8. And that's angle side angle, or the ASAP ostulate. Now I can say that NR is congruent to NI. And that NA is congruent to NB. By CPCTC. Uh-oh. Gonna need more room. And then step number 10, I can say let's see, the segments bisect each other. It's a little ghetto. I kind of forgot which segments we were trying to show. And that's going to be the definition of bisect. Boom.